The purpose of today's experiment is to measure the coefficient of kinetic friction between the surface of this slider and the surface of this track. I will allow this surface to move on the track, and we will use the principle of work energy theorem to figure out the coefficient of kinetic friction. Now, do you remember the concept of work energy theorem? Well, when I place this block, I'm going to call this the block. When I place this block at a height h, I will ask you to measure the height h. It has a potential energy, and when I leave it, it is going to slide down, and when it reaches the end, it will have kinetic energy. So you will measure the potential energy and you will measure the kinetic energy when it reaches the bottom. Now, how do you measure the kinetic energy? Well, you need to measure the speed of this when it reaches the bottom. And in order to measure the speed, I'm going to use this metal strip. Now, you have a photo gate here. When this metal strip blocks the light, the time for that will be registered by this clock. Now watch what it does when it moves in and blocks the light. Now what the clock has read is the time duration for this length to block the light. That means if you know this width, I'm going to call it delta x. If you know this delta x and knowing the time, you can calculate the speed of this by delta x divided by delta t. Alright, so you will know the potential energy, you will know the kinetic energy. If no energy is lost while sliding down, well, that is not true. Some energy is lost. Is that right? Now, what is the measure of energy lost? The work energy theorem says that the lost energy, or the difference in the energy, the initial energy minus the final energy, I'm going to call it delta E. Now, remember, delta E is the potential energy minus the kinetic energy. I'm going to call it mgh minus 1/2 mv squared. Now that is your delta E, the change in the energy. What does the delta E equal to? The delta E is a measure of the energy lost while sliding down, which is a measure of the work done against friction. So we're going to say delta E is work done against friction. Well, if the frictional force, I'm going to call that F sub k. If F sub k is the frictional force and L is the length that the block slides down, that is this length, I'll be asking you to measure that length. Then the frictional force multiplied by that L will be work done by that frictional force. So, putting it all together, I can now write the equation mgh minus 1/2 mv squared, which is delta E. So I'm going to say delta E therefore equal to the force of kinetic friction multiplied by the distance the block slides down, that length L. Well, now the question is, what is that force of kinetic friction? Now, is it possible for us to figure that out? Well, let me see if I can draw that inclined plane. Now, this is the inclined plane. The inclined plane is of inclination theta. Well, you will be required to measure this angle of inclination. Can you figure out how to measure that? I will give you a couple of measurements. Well, I will ask you to take a couple of measurements and use them to find that angle. So we've got an inclined plane of inclination theta, and this is the block at some time on its journey down the plane. Now, what are the forces acting on it? You know that its weight mg will be acting vertically down. Then mg cos theta will be pressing the block onto the inclined plane. Mg sin theta will be pulling it down the plane. And the normal force Fn is the same as mg cos theta. Well, you know all these things. Well, what is the definition of coefficient of friction? Do you know the definition of coefficient of friction? In theory class, we discussed that the force of friction, this time it is the force of kinetic friction, is directly proportional to the normal force. The normal force is mg cos theta, and the constant of proportionality is the coefficient of friction. So Fk equal to mu k times the normal force, that is mg cos theta. So look at this now. You have Fk is mu k times mg cos theta. Well, you will know the value of m, the mass of this block. In fact, I will ask you to measure it. The angle theta you know, therefore Fk can be figured out. Let's now take this equation and put it here. And in place of delta E, I'm going to write this. Delta E therefore equal to Fk, I'm going to replace as mu k mg cos theta. Now that is your final equation. Delta E equal to mu k mg cos theta. And you need to now use this equation and obtain the value of mu k in the experiment. Well, we forgot one quantity here. What is that quantity? Delta E is Fk times L, the distance the block will move down. So Fk is mu k mg cos theta, multiply that by L. Alright, so what you will be measuring will be, you will measure delta E, knowing the potential energy and the kinetic energy. You will measure delta E for different values of L. In other words, I will slide the block from this point and you will be able to measure the height to figure out the potential energy and the length L. Now the length L is measured all the way to this point where I am pointing, right? From the center, I will make a mark so that you know the center of the block. Now I will allow the block to slide down from different heights. That means I am varying H and L. So L will be a variable, H will be a variable. When H changes, V will also change. That means mgh minus 1/2 mv squared, which is delta E. So delta E is one variable, L is another variable. Can you write this equation in the form y equal to mx? Okay, I'm going to leave it for you to do that. Delta E is one variable, L is the other variable. Now tell me which is the independent variable. I'm going to ask you to take L as the independent variable. Delta E is then the dependent variable. So this equation is actually in the form y equal to mx. And so the slope of your graph will be mu k mg cos theta, and from the slope you will be able to obtain a value for mu k. So that is your experiment, right? Okay. Your data set will look like this. You need to have the mass of the sliding block. You need to know delta x, the width of this block. You need to know the angle of inclination. Alright, let's do those three things first. Okay. To begin with, we will measure the mass of the sliding block. Alright. I want you to measure this mass. Okay. Alright. I hope you finish measuring the mass. Now measure the width of this metal strip, that is your delta x. So measure delta x from this ruler and record it. Okay, you have measured delta x. You have now the value of m. You have the value of delta x. You now need to obtain the value of the angle. In order to measure the angle, I'm going to ask you to measure a couple of distances. And in order to measure distance, you need a conversion factor. Alright? I want you to measure the length of this ruler. This is the 30 centimeter ruler that we very often use. Alright? Measure the length of this ruler and write it as x centimeter. Alright? Measure this and write it as x centimeter. I'm going to keep it here. Okay. And work out the conversion factor. What is the conversion factor? Alright. Conversion factor C equal to 30 centimeter divided by x centimeter. That is your conversion factor. That means any distance you measure will be multiplied by this conversion factor so that you get the real distance. Okay? So, obtain the conversion factor and write it down. And in order to measure the angle theta, I'm going to ask you to measure two distances. Alright? Measure this length. Now, when I say this length, look at the left extreme where I'm pointing. That is the left extreme, and this is the right extreme. Measure that length. If you know this angle, this is the adjacent side for that angle. Okay, once you measure that length, then you need to measure the height. Now the height is measured from this point. Alright, I'm going to give you now the height. Measure the height, which is the distance up to where I'm pointing. I'm going to do it with my red marker. So measure the height from the tabletop up to here. That is the height. That is the opposite side of the angle. So you have now got the adjacent side. You measure that length. And then we just measured, or if you haven't, do it again. That is the height. Measure that height, and of course multiply it by the conversion factor up to the center here. Alright. You now have the adjacent side and the opposite side. Use those two values to find the value of theta. So you have all the preliminary measurements now, and what we are now going to do is keep the trolley at a height h, and you will measure that height h. Alright, let's start. by keeping the trolley here, measure the height h. Now, where is the height going to be measured? I have given you a reference line on the table. So, points on the table, you need to measure from that point to the center of the, so you need to measure from the tabletop to the center. Alright, that is the height. Alright, measure the first height and enter it in the table and calculate the potential energy U equal to mgh. Alright, I'm going to reset the clock. I want you to look at the clock and see how it is read. If you're, well, you have been using this, so how is the clock read? Watch this, it is 00 point. After the 2 digits you have a decimal. So what you see here is 0.7019. That is what is read on the clock now. 0.7019. I'm going to now reset the clock. Okay, I want you to measure. I'm going to allow this to slide down from the height h you just measured and measure delta t shown by the clock. Alright? Okay, that is the delta t. Measure that. Now, I want you to repeat it 3 times. So take the first measurement of delta t. I'm going to reset it. Alright, take a second measurement. Okay, that's the second measurement. You can see they're different, so you need to really repeat it several times. Alright, I'm going to reset the clock. Take a third measurement. Alright, we have 3 measurements now. Now, use those 3 measurements. When you make your tabulation, see what I'm giving you is a guideline. When you make your tabulation, you must have delta t trial 1, trial 2, trial 3, average. And that must be recorded. So, obtain your delta t, calculate the velocity. V equal to delta x divided by delta t. Delta x you have already measured. And use the velocity to calculate the kinetic energy. So now you have the potential energy in this column, the kinetic energy in this column. The difference between the two is your delta E. And what else do you need to measure? You need to measure the length that is traveled by this block. Well, the length is measured from the bottom point of the inclined plane where I'm pointing. In fact, it's very clear there. It is where the timer starts. So measure the length from this point to the middle, that is the dot. So measure the length from the bottom of the inclined plane to the center, you see, up to here, corresponding to that dot. Measure that, that is your L. Okay, now we will repeat it for different values of H. Alright? Now, measure first of all H. I'm going to start now from here. Measure this H. Now remember, H is measured from that red dot to a point on this wire. That must be a vertical line. Is that right? Measure that vertical distance. Measure that H, and of course multiply it by the conversion factor. And now measure also, before you make the time, it is better to do all the measurements. Measure your L. L is measured from this point all the way to the bottom. So measure your H and L and record now. Okay. And now let's do the first trial. The first trial for that H. All right. You have the first trial time. I'm going to reset the clock. Let's take the second trial. All right, the second trial. Measure that time. Reset the clock. And now the third trial. Okay. Measure that time. You have now 3 time measurements. Take the average for your delta T. So for the second trial you have measured H. You can calculate potential energy. You have 3 trials of delta T, find the average, use that to find V, find kinetic energy, and find delta E. You have measured L already. Okay, let's now do the third H value. Alright, I want you to measure H and L here. Measure H. The vertical distance. All right, measure H and L. L is measured from below the dot on the track all the way down here. So measure H and L, and I'm going to give you 10 seconds to do that. Measure H and L. There you are. You can actually stop the video and do that. Alright, let's do the first trial for the time. This is the first trial. Okay. Let's do a second trial. That is the second trial. Reset. I'm now going to do a third trial. Alright, we have 3 trials for that H and L value. Reset the clock. We will now repeat it for the next H value. Alright, measure H and L here. Measure H and L. Okay. The first trial. Measure your time. Reset. The second trial. Okay, reset the clock. The third trial. Okay. You have 3 trial time values. Find the average and calculate the velocity and hence delta E. Reset the clock. We will now repeat the process for this H and L. Alright, I'm going to give you 10 seconds, or just stop the video, measure the height, the vertical height. That's the vertical height you need to measure from the tabletop to the dot. Alright? Right, you got to choose a point on the string that I have provided and measure the vertical height from the dot. Measure H and L. Okay, let's do the first trial from that height. That is the first trial. Reset the clock. Let's now do the second trial. Alright, that is the second trial. Reset the clock. Let's do a third trial from that height. That is the third trial. I hope you are reading the time intervals correctly. Reset the clock. We will now repeat starting from here. Okay, I'm going to give you 10 seconds. Measure H, the vertical height, and the length L. Okay. Let's do the first trial for that height. First trial. Measure the time. Reset the clock. The second trial from there. There you are. Reset the clock. And now the third trial from that point. Okay. We got 3 trials. Measure the average time. Reset the clock. Now we will do it from a different height. Measure the height H and length L at this point. Okay? Trial 1. Measure the time. Reset the. Now the second trial. Okay, let's do the second trial on that height. That is the second trial on that height. Measure that time. Reset the clock. Let's now do a third trial from that height. Third trial. All right, reset. Let's now do at another height. All right, that's a new height. Okay. Measure the height and the length L. All right. let's do the first trial. That's the first trial. Reset the clock. Let's do a second trial from that same height. The second trial. Reset the clock. And now a third trial from the same height. There we go. Okay, you have 3 trials from that height. Reset the clock. Let's now go to the next height. Alright, you can see where you measure the height now. Now measure the vertical height and the length L. Okay. The first trial. That's the first trial. Measure that time. Reset the clock. Let's do a second trial from the same height. Second trial. Reset the clock. And now a third trial from the same height. Alright, we have 3 trials from that height. Find average delta t and the velocity. And finally, let's do, well, maybe a couple more. This is the new height. Alright, measure that height and measure that length. Measure the height and length now. And let's do the first trial. There it goes. That's the first trial. Measure the time. Reset. The second trial. There we go. Reset the clock. And now the third trial. Reset the clock. Measure the time. I'm going to reset the clock. Well, I'm going to try one more for you. The last trial, measure this H and L. So that's your H. Always measure from the tabletop to the center of the red dot. That's your H. And measure L. Okay. And let's do the first trial. There we go. That's the first trial. Okay. Reset. Let's now do the second trial. There we go. Reset the clock. And now the third trial. Okay. There we go. What we have now, the complete data for the experiment. Alright, complete your tables. These tables will be a little complicated for you to make, but take some time and do it well. Remember, all the units must be written in the proper form. It's very important. And draw the appropriate graph. Obtain a measure of the coefficient of kinetic friction between the two surfaces. Okay, I think that's about it. And if you have any questions about it, let me know, and I will see you for the next lab later on.